Hello and welcome to As We May Think. On this video, what I wanted to do is talk about filtering. If you're like me, you're shipping more and more data to the front end than you have ever shipped before. I actually have pages at work where we ship 100,000 items. That's individual JSON objects to the front end, and then we rely on the front end to deal with those objects because it can take quite a while to get the data. We can actually cache it on the front end so that the next time a user arrives on the page, they get the cached version for a brief period until the new version arrives. You see that sometimes if you've used, for example, Google Mail. Gmail, when you first arrive on the page, you notice your old version of your inbox, even if you've modified it from another machine, and then you see it updated with new email coming in over that. That makes for a good user experience. They see data almost immediately. They don't have to wait for the first API call, and they see a blank page until that actually arrives. With more data, yes, you are correct if you're thinking, oh, well, we have Elasticsearch, or we have Solr, or we have some other nifty search engine in the background. And if you're Google, great. Because I believe that you can turn around a search to the end user in practically no time. If you're almost anybody else, I think you need to think seriously about doing some filtering and some searching on the front end if you can for a good user experience. It's really tough when I know this from timing on my own machine. If I can do a filtering operation in under 10 milliseconds, which I can do that against maybe as many as 1,000 items. I can perform simple filtering type operations to say I'm only interested in these specific items or subsets of items. That can happen in under 10 milliseconds on the front end. And then true, we're going to spend a fair amount of time re-rendering the data to redisplay the subset of data, but you'd have to spend that time anyway, even if you did a full round trip to the server to send the request for the filtering, for the server to do its thing, and to send you back a new set of results. That would be very tough to do for most people in under 10 milliseconds. So there are good times when you want to be able to do filtering on the front end. The thing is, I have not found a lot of libraries. Well, I haven't found any libraries to help you with filtering except this one. This is pretty much the only thing I've found that really helps you deal with filtering a large subset of items and do so in a sophisticated way. And you're probably going to call me a hypocrite here in just a second, and here's why you're going to call me a hypocrite. Just a few weeks ago, we were looking at routing libraries, and I dissed one of the routing library choices that was out there. It was a very popular one because it hadn't gotten any love in about, 5 years or more. And here I'm about to suggest a library that has the same problem. If we go to the GitHub page for it, and then from there, I believe there's actually a fork of it. It is kind of the official fork. You will see that there hasn't really been any love to it in 4 years. That's a long time. But because this is about the only choice for this kind of thing out there, I'm still going to recommend it for you for the moment. Maybe someday at some point there will be another better choice, but this is pretty much it for the moment. So what does Pour-Over actually get you? Well, it gets you a set of filters that can be very easily constructed, ANDed, and ORed with each other. Basically, typical Boolean type operations to get you to the final set of information that you're interested in. They've got pretty good examples here. In their examples, they show a lot of code. And they start with this set of mythological creatures, each of which has a given sex, different hobbies. These kind of things reflect fairly well the kinds of filtering operations you might need to do. And I wanted to do, for my example, something similar to this, but I wanted to give you a fair bit of code to play with, so I did. Here is my example. What I did was I started from this list of the quote-unquote best artworks of all time. It was 50 influential artists. This data set was provided by Icaro, and I want to give full credit to him or her, whomever this is. It's a great data set, and I'm using it here. I want to make sure and plug it. I have taken that same data set and I've made it available in my data sets. All I've done is take the CSV and convert it to JSON so that we can embed it easily. And I've pulled all the images so that we can use those as well. I wanted to play a little bit with Bulma recently. So Bulma is what I'm using just for a CSS framework. I wanted to be able to have cards and some other stuff. And so for that reason, I could have used, trust me, you didn't want me to design it myself, so I had to use something. But I could have used Bootstrap or Foundation or any of those things just as easily, but I used Bulma in this case because I wanted to see what it looked like and how it felt like. So this is the final result. Let's talk a little bit about how I started the code, and then let's go back to how the code actually works. So I started with this. Well, I started with the data, first of all. This is the actual data converted to JSON. So this is the data set, and I made sure to credit it correctly. And then I created a single lit element component. This is standard web component. If you aren't familiar with web components, be sure to watch my video series on web components and specifically on lit element web components. This is a very simple example. What I did was I took the Bulma card example where they had an illustration on it, and I just yanked that straight out of there and I put that into the render of this component. I added a couple of styles to it because I had some problems with how the images were rendering in these little boxes. They were getting distorted if I just pulled them straight in, so I added a small amount of styling to get that fixed. That's it. That's the only thing I changed there. Then I actually plugged in where I want the data to appear. So this is the data. And I said that the only thing that gets passed to this component is the artist, which is of type object. So far, so good. You can ignore the toggle favorite. We're going to cover that in the, and also the favorite icon. Both of those we're going to cover in the next video. They are not relevant to the current one. This just makes sure that it shows whichever image number. In the example data provided by the Kaggle data set, it came with a large number of images for each of these painters. You can reference any of the images. I just arbitrarily picked the very first image to show for each one. And so that's why it says somewhere here, image 1. So I'm always showing image 1 right now. This object was the card, and we're done with the card. The rest of the work shows up in this, in the filter page component. So I did a component for the card, and then I did a page level component beyond that. Into it, I pulled all of the great artist data that you saw a minute ago. Let's go ahead and close that. I pulled in the component for the cards, and you can ignore this particular one because that's going to be covered in the next video. So now here's yet another component. This is the page level component that has both the filtering controls in it and the whole array of cards. So in its rendering is in many ways even simpler than the other one. There's some chunks up at the top that have to do with the various filters that you see, and then below that is simply a map that takes all of the artists and generates one card for each one, passing the artist in for that particular card. That got me all of the cards rendered. Then I wanted to do a couple of other things. So in the original data that you saw that I got from the data set, all of the genres for a given artist were all in one string. And similarly, the nationalities listed for a given artist were also listed in a single string. I used two set objects. Sets, you may have watched my video about sets and maps in ES6. If you haven't, you really ought to. They're great tools. A set can only have a given string added to it one time. After that, any number of additional adds, it doesn't add it again. So I used this to cycle through all of the artists, pull out all of their genres, and then add each one to the set. So I ended up with basically the complete list of every genre that appeared on all of the artists. Did the same thing for nationality, and then I had 2 sets of the 2. I used array from to turn those sets back into arrays, because arrays were way easier to work with for the rest of the code. So once I was done with this, I had an array of all the genres and an array of all the nationalities. If you've watched my debounced, no, let's not cover this now. This is about searching. We'll cover it in the next video, so let's ignore this. So at this point, I had successfully gotten the complete list of these, and that's the code you see right here that actually gives you checkboxes for all those things. Ignore this first one, it's for search text, but here's the list of all the genres. It takes that map and turns them all into checkboxes. Each one, whenever you trigger it, calls toggle genre and passes both the event and the actual genre in question. The same thing happens down here with toggle nationality. So these functions are what get called whenever you check or uncheck one of those boxes. So how do I actually wire this to pour over? And let's talk about pour over itself. These examples are pretty descriptive of how pour over works. You create a pour over collection, giving it an array of objects. These are the ones that you actually want to filter. Then you create a series of filters that are the things you're wanting to filter on. It has built into it a couple of different specific filters. One's called Make Exact Filter, which basically is about those cases where you have some characteristic of the objects that are only going to have one value. So in this case, mythology, all of these creatures, these mythological creatures, are either specifically Greek or Norse, or they have a sex of male or female. They don't mix in these cases for this sample data. But hobbies, they make an inclusion filter, because for a given mythological creature, it might have several different hobbies, and they're almost like tags in a way. The same thing might occur in multiple places. So when we do this for the artists, we're going to use an inclusion filter for both genres, because some of the artists have multiple genres that they worked in, and we're going to make an inclusion filter for nationalities because several of them have multiple listed nationalities. They didn't necessarily live and work the entire life in one particular nation. Once you've created these filters and given them examples of all the different kinds of things you might want to filter against, then you come in and add those filters to your collection. You can pull a given filter out, and you can say, this is true for that particular filter, and this is true for another filter. You can AND those filters together, and then the result will be the exact collection of IDs of the items that passed. Now, ours is a little more sophisticated than that because we allow for multiple selections. So let's look at, having seen what you just saw, let's come look at our code and how we do it. Here is the initializing of pour over. I create a collection. You saw this before. I add a series of filters. I make an inclusion filter for genre, and I make an inclusion filter for nationality. There's 2 more filters here. Don't worry about those. We're going to cover them in the next video. And then I trigger the filter. We'll talk about the filtering code in just a minute. So as they check the various checkboxes, we saw the checkboxes. We know that they're going to toggle either, they're going to call either the toggle genre or the toggle nationality functions. So let's look at what those functions actually do. It comes in here and it says, if it was checked, then we want to add the genre to the genre filter. So whatever genre they clicked on, if I come and I look at this example, if I click social realism, then social realism gets added to the filter. If I add more of them, you'll notice I get more items, because all of those are getting effectively ORed together it's a union query in this case. Each one of those is getting unioned into the filter. If I come through here and I uncheck some of these, then remove single query is happening, and those filters are going away. They're actually getting removed. That particular item is getting removed from the filter. So this is how genres is handled, and then we trigger filtering again. So every time I check one of those, it redoes the filtering to actually decide what items should be shown. If you look at nationality, it's almost identical, except that now we're dealing with the nationality filter, and we're bringing in either the nationality or removing the nationality from the list. We used to write code that did all this at work. This was not uncommon for us to write code that performed a series of tests against JSON code based upon what we had checked and unchecked in various filters. You can absolutely do that. We did it. You can do it too. There's nothing magical about this code, except it provides a good framework and it works well. And it does some steps that you might be tempted to skip, steps that we used to skip. For one thing, as you create the collection and as you tell it about, here's an inclusion filter that I'm interested in having, it creates an index of, for example, all of the genres that it sees on those various artists, all of the nationalities that it sees on those various artists. For small numbers like 50, that makes very little difference. But when it comes to 1,000 or more items, or even up to 100,000 items, it makes a huge difference, because now all of a sudden it's not just doing a blind search through all 100,000 items and then maybe a few lines later performing that same kind of search again blindly against 100,000 items and going over the same data n times trying to do different operations in a inefficient way. Here it's actually performing, it's done an index beforehand, and it's making use of that index to get to the results very, very quickly. So that's one of the reasons why I think pour over is an excellent choice, especially if you have a lot of data. Let's look at what the actual filter does, and then we'll probably wrap up for this video, and then we'll come back again and I'll show you how we can use more filtering. So we start from all of the artists. This match set is basically every single artist. If there was search text, I do something with that. We'll ignore that for the moment. We're going to come back to it. But we do have both genre queries and nationalities that could occur. So what I do is I look to see if the genre is currently active. Is there any query right now, and does it have anything in it? If it does, then I AND all of those genres together with the matches. So if you had selected 5 different genres, then it would now accurately get to those 5 all the artists that were in those 5 genres. And then if you go with nationality, it does the same kind of check here. Is there nationality queries? If there is, apply that filter as well. And then finally, this favorites, we're going to ignore that until the next video. But you'll notice that all we're doing is ANDing a series of filters with the master set of artists. That's it. So the structure of this has gotten pretty darn easy, and that makes it easy to add additional filters or tweak how these filters work. You can absolutely do all of this. So if I say Dutch, let's see, I bet one of these, okay, one of them was Belgian. So let's see, just for sake of Belarusian, no, Belgian, come on, John. Belgian, there we go. So you can say, all right, we've got Belgian. So here I am applying multiple different things, and all of them are working together. That's simply an ANDing of the various steps, which are themselves ORing together multiple different genres. So effectively, these are all being ORed together, these are all being ORed together, and we are taking this search text, ANDing it together with whatever genres, ANDing it together with whatever nationalities, and then finally ANDing it together with favorites if we have those. These two we'll cover in the next video, and I think you'll see why Another reason why this is really great, I go through all the artists and I mark each one to not be shown. I simply set a simple Boolean value on it, don't show it. And then I come back in and I look at the final set of matches and I say, give me all the IDs that matched, and then I'll mark every single one of those to be shown. If you look down here, you will see that if a given artist is not marked as show, no card gets created. I don't know about you, but this code is both significantly simpler and significantly faster than any of the filtering code that we've done in the past for our really large data sets that we deal with at work. If you have a big, complex searching and filtering operation that you need to do on the front end, I think you should seriously consider pour over, and in the next video, I'm going to show you some additional reasons why. Thank you so much for listening again to As We May Think. I appreciate your viewership every single time, and if you enjoyed it, please click like and subscribe, as well as the notify bell that you see on your screen. That'll let you know whenever a new episode drops, which is normally Tuesdays and Thursdays. Again, thank you so much. Bye-bye.